All right, so here we are. We have Bayes' theorem. It's in all of its glory. So what is the probability of B given that A occurs? Well, we know that it is the probability of B intersect A divided by the probability of A. That's our definition of conditional probability. But let's say event A is kind of complex. We know that from the previous section, probability of A is given by this total probability formula. The probability of B times the probability of A given that B occurred, plus the probability of not B, plus the probability of A given that not B occurs. And our probability of the intersection is equal to the probability of B times the probability of A given B. So let's put this beast to use. At a university, there are 65% female and 35% male students. Only 25% of the female students are taking statistics, while 60% of the male students are taking the course. A randomly selected student from the university is taking statistics. Find the probability the student is female. So what we're looking for is the probability that the student is female given that they take statistics. So using our conditional probability formula, we know that that's equal to the probability of F intersect S, where F is, of course, the student is female, and S is that a student takes statistics. And using our Bayes' theorem, we have this formula now. Probability of F times probability of S given F divided by the probability of F times probability of S given F. It's the same as what's on top here. Take notice of that. Plus the probability of the other thing. So probability of a male times the probability of statistics given a male. This bottom is the probability that a student takes statistics. Whether they're male or female, we don't know, but that's the probability that they take statistics. So take a moment and create a tree diagram for this situation. So you should have a tree diagram that looks like this, and now we have all the numbers that we need for Bayes' theorem. We can plug them in and do our calculation. So, what do we see here? What do we need to take into account when we're looking at the probability of F given S? I try to remember that this thing on top, the order can sometimes be a little bit confusing, but write it as probability of first intersect second. You don't change them around. And then this intersection on top becomes probability of F times probability of S given F. There's a little bit of an order that makes a difference here. So just be very conscious as you're setting up with Bayes' theorem. So let's go back to our jar with marbles problem. We had this tree diagram in our previous video with the probabilities, and we had the three different hypotheses. Hypothesis 1 was taking 2 green marbles from jar A and putting them into jar B. Hypothesis 2 was taking 1 of each. Hypothesis 3 was taking 2 purple marbles from jar A and putting it into jar B. So now this question is, what is the probability that two marbles of different colors were transferred from jar A? Okay, but we also know that a randomly drawn marble from jar B is green. So we know the outcome. We know that we picked a green marble, but we don't know which of these hypotheses it was. We want to know what the probability that it was hypothesis 2. So we're trying to find the probability of hypothesis 2 given that the marble was green. I would like you to pause the video right now. This is important. Pause the video and try to apply Bayes' theorem to this probability situation. So the numerator, we should have probability of H2 times probability of green given H2. In the denominator, remember, it starts the same way. That's the probability of green given H1. And then we have H2. And then we have H3. This is a big, meaty problem. We have 3 different hypotheses. We don't know which one happened. And now we take the values from our tree diagram and we plug them into Bayes' theorem and we run our calculations. So for this problem, we did have to do a lot of building work in the first video. We had to find the probabilities that go on this tree diagram, and we had to figure out that there were indeed 3 different hypotheses, and some of these probability formulas, these probability scenarios that you're going to be given are a bit intense, and you have to be careful in paying attention to the things that you are looking for and trying to find, and really analyzing the situation and what the different possibilities